So the way that we set them up is the outdoor air comes in through the dehumidifier. Of course, there's a mechanical damper and it goes into the return. We set these up with 2 call switches. The first one is when the fan's on, the dehumidifier's on. So when the fan's on, we're bringing in outdoor air, but the dehumidifier has a fan as well. So we're using the dehumidifier fan to help push and then, or help pull and then push air into the return. So that's how we're getting more efficiency with less open of the damper, is we're actually pushing and pulling air into the house now. So you've got MERV 10 filtration here, MERV 12 to 14 here. So we know we're diluting, twice filtering. We know we're getting good bang for our buck. It's dry, twice clean air coming into the house. You know, the damper I think is like $150, so $1,000 for the higher end dehumidifier, and then some ducting, and the thermostat's a couple $100. The rest goes to the guy installing it.
A water-resistant barrier, a flashing. The water-resistant barrier seals to the window. The window is a manufactured item with its own internal liquid water control. Back to the water-resistant barrier, a capillary break between the concrete and the framing. Capillary break at the edge of the slab, and a capillary break beneath the slab. So you see how that works? This is very useful if you're reviewing drawings. It's very useful if you have a problem building and you do this with the existing conditions and figure out where are my weaknesses. You can do the same thing with the insulation layers. You can draw a line through the insulation layers, establishing continuity. You can do the same thing with air barrier. And in this particular building, notice that in the roof system, the air, and as it turns out, vapor barrier, are one material, and they are different than the liquid water control on the roof. On the wall, the air and vapor barrier and liquid water barrier are all one material on the wall. So you have one material serving all 3 functions.
So mold and mycotoxins, I don't know how many of you have heard of mycotoxins or familiar with them? A couple people? Okay. Everybody. So people think that they're the same, and as I said, they're, you know, being sarcastic, right? No, absolutely not. In just about every way, they're different, other than the fact that they're both produced by molds. So the mold VOCs are volatile, where the mycotoxins are much less volatile. So they tend to settle on either spores or dust or other kind or surfaces and get carried through that way as those spores and dust move throughout the building. The VOCs aren't limited by that, so they can go through walls and move more quickly through those kinds of spaces than the mycotoxins can. As I mentioned, they're primary metabolites, so they produce during active mold growth. The mycotoxins are secondary metabolites, so they're usually produced when the mold is threatened or it's expanding. In other words, that colony is dying out and it's going off to make a new one. So they actually are produced, again, at different points in the mold's life cycle. They are similar in that there's a lot of them. So there's a lot of different mold VOCs, and there's a lot of different mycotoxins. Mycotoxins tend to be grouped into, well, chemical classes essentially, but they're more specific than the mold VOCs, like trichothecenes or aflatoxins or those kinds of things. If you've heard those words, those are mycotoxin groups. Mold VOCs, because they are volatile, are really more responsible for that moldy odor than the mycotoxins. They're not particularly involved in that, but
this is an example of one that's been retrofitted. This is actually the best house of all. It has a MERV 13. This duct used to be a straight narrow duct, and the filter used to be a 1-inch filter. The static was off the charts. So we modified the return drop, put in a MERV 13 filter, plus they have air cleaner in the house. They run both continuously. But okay, so what we did was the air handler inquiry is what's been fascinating to me. I think we might have tested 15 to date. We know that if you have an air handler with any filter, a 1-inch filter, a 4-inch filter, and if you run that air handler continuously, you'll be really surprised at the numbers on both the Dylos and Spec. However, external static is high in every single system we found to start with. The air handlers are set. We haven't found one yet that if you have a thermostat and it says continuous, which is what you typically do if you want to run your air handler continuous, they run the air handler on the highest setting, on the same setting as with cooling. I mean, you don't want to do that. We're measuring the watts, the power, and we're seeing the best, the best before we mess with it might be 700 or 800 watts. The worst is 1,500 watts. If you're using 1,500 watts continuously, that's 36 kilowatt hours a day. I mean, so yeah, you got clean air, but you might be killing your system because the total external static is so high.